Alright, so have a warranty case of the manufacturer that we do a bit of, well, a lot of their warranty repair work for. This is a top discharge pool heat pump. They're reverse cycle, these ones. So we've got water inlet down the bottom, water out the bottom. This one was actually installed right against the fence, covering up. So this side was facing out, so you could just access it squeezing between pumps. And this side here was the only free side. This side here was covered up by a fence, even though the controller's there. The controller, they decided to cut a little flap in the fence, a little slide bolt. And this one here was covered up too, so pretty well completely covered, so no airflow. So still not running, so we'll open it up, we'll see what the story is. Cool, so I've just had that unit off for quite some time. Just starting up here, I just want to try and see if we can catch this electronic expansion valve driving for you. Yes, you can hear it. Alright, so we have got this one here hooked up to our shop power here. This socket here is what we usually use to bench test equipment that we bring back to our workshop to fix up. So this is actually still just wired up like how you would in the field. There's nothing special about it, obviously. But what we want to do is just prove always, even though we know that we've got decent supply here, 239 active to earth, and then we're just going to go neutral to earth to make sure we've got good polarity, decent neutral, etc. So that's happy days. Now, when you first fire up this unit, what you'll hear is some ticking noises coming out of the electronic expansion valve here. So that's all sweet. Basically, this unit has had somebody else work on it. Apparently they replaced the fan. I'm not sure how they got into it all to replace the fan, especially considering like all the factory fitted cable ties are still in place. So it's a bit odd. But that being said, so maybe they fit some newer, maybe they had some small cable ties to replace it with. But this little Molex plug here was actually out, so it was only making contact on the red, the black, the white, the yellow, and the blue was barely making contact, so that's probably caused some dramas. Then indicator LED on that one there is saying it's good. No indicator LED on the COM board at all. And the main issue with this one is the screen wasn't working. So as you can see, this is like a touch screen user interface. Sorry, well, but yeah, just dead, nothing at all there. So first things first, we'll check voltage at that board. Cool, so got the Fluke meter set up here. Got these really handy little, I don't know if you can see, but that's how thick they are compared to a little terminal screwdriver, so quite tiny, very handy for this sort of work here. So what we're going to do here is, you can see we've got our voltage. If this thing would focus, we just want to check voltage here. So we want to make sure we've got 12 volts coming into this board. So 4.234 volts, so definitely not enough for what we need. Alright, so I've actually unplugged the controller from the wiring loom in case there's a little short within the controller anyway, which I don't think there was, but you never know. So we'll come back over to here. So now we want to just make sure that we're testing the right cable. So we've got this cable here, which is actually in there. So just bear in mind that this is all live as well. So again, 12 volt positive is this pin here. And my next pin down there, so as you can see, it's quite like good luck doing that with your normal multimeter probes. So we've still got 4.28 volts DC exiting that board, the comms board, from the main inverter board. So there's only 2 boards in this one, and there's a reactor sitting up in there. Alright, so we need to make sure we've got voltage into this board as well. So here, 12 volt DC, again coming into the comms board on those little pins there. So this is all still on, so just being careful not to touch anything we shouldn't. It's still early in the morning, it's only like 7 o'clock. So yeah, power into that board is no good either. So we're just going to disconnect the power in and make sure we don't have any shorts happening here. So I've just disconnected. That's the actual cable that supplies. It goes back down under there, back it wraps around into there. So you'll notice that this is actually starting to freak out. Electronic valve started making some noise as well then, as soon as I disconnected that board. So just going to check our voltage out of that one there. So on this wiring loom, 12 volt active is black, 12 volt ground is red, so it's sort of backwards. It says there, so 12 volt, that's a G. So we're going to come up to our pin. And we're getting nothing. So it could be because we've disconnected it for too long, didn't test it quick enough, I think. But so we've got 4.3 volts as well. I'll try and show you that on the camera once I can get this to stay in place without me moving it around too much. Wobbly hands. There it is. So on this particular fault, the main inverter board isn't actually outputting a DC voltage to the comms board. I've already actually ordered a board from the supplier because 9 times out of 10 it is that. We can always just send them back if we don't use them for these warranty cases. But there you go. Quick way to check to see what your comms voltage is on a heat pump.